What I want to do in this video is introduce you to the idea of a consumption function. And it's a very simple idea. It's really just the notion that income in aggregate in an economy can drive consumption in aggregate in an economy. Consumption in an economy. And just to make things tangible, I will construct a consumption function for a hypothetical economy. And we can debate whether we can construct a better one. And it doesn't have to be, all the numbers don't have to be exactly what I'm about to do, but this is just to make things concrete in your mind. So maybe we have a hypothetical economy where consumption is going to be equal to, well, maybe there's some base level of consumption. Even if there's no aggregate income in our economy, it's hard to imagine, but let's say there isn't, there will still be consumption. Maybe people can do it by digging into their savings. So they're essentially using resources that they've already accumulated in some way. And let's say that base level of consumption, let's call that 500. 500, it could be billions of dollars or gold coins or clamshells or whatever the unit of measuring economic activity is in our economy. So that's our base level of consumption. And then let's say if there is some aggregate income, people will spend 60% of it. And I'm just picking these numbers somewhat arbitrarily. So let's say if there's some above and beyond the base level, they're going to spend 0.6 of any aggregate income they have. And actually, to be a little bit more particular, I'll write not just income, I'll write disposable income. And I want to do that in a different color. That's not a different color. They will, above and beyond the base level, will spend 60% of their disposable income. Disposable income. And I make the distinction, just to clarify our model, between income and disposable income, because all of the aggregate income in an economy does not end up in consumers' pockets. And just for simplification, you might say, well, yeah, some of it ends up in firms' pockets, but the firms at the end of the day are owned by individuals, so it can end up in individuals or consumers' pockets, but some of it goes off to the government. It goes off to the government. So when you think about income, and if you spend any time looking at your pay stub, this will become familiar to you. You have your income, but you don't end up with all of that in your checking account or your pocket or your savings account. A good fraction of that is taken out for taxes. And so what you have left over when you subtract taxes out of income, that is your disposable income. Disposable income. And that's why I write this here, because that's actually a more reasonable thing to say. People will spend 60% of their disposable income. They obviously can't spend a fraction of stuff that they don't have, the stuff that's taken out for taxes. And just to visualize this, we can draw it. This will be a line. This might ring a bell from your early algebra days. It's just the variables are different. Instead of a y, we have a c, but that's still the dependent variable. It's a function of disposable income. In algebra, you'll often call this the independent variable. Sometimes the most typical variable is x, but it's really the same idea over here. So let me draw this a little bit neater. So we can graph this, what's essentially going to be a line. It doesn't have to be a line. We just constructed a consumption function that happens to be a line. So this is consumption right over here. In the vertical axis, that could be in billions of dollars or clamshells or whatever else. And then right over here, we have disposable income. Disposable income. And so if there is a zero disposable income, maybe I'll draw a little table right over here. If I have zero disposable, so this is, I'll call it disposable income, and this is consumption. If there's zero disposable income, then this whole term right over here is zero, and then you have $500 billion, or whatever our units are, of base consumption. And then that would coordinate, this would correspond to this point right over here. In the horizontal axis, you don't move at all, because this is zero. Vertical axis is 500. So you have 500. And let's say disposable income is, let's say that it is 1,000, whatever our units are. So this is 500. Let's say this is 1,000 billion clamshells. So this could be in billions of clamshells. So I don't want to keep having to say that over and over again. Well, what is our consumption going to be in our units? Well, our consumption is going to be equal to 500 plus 0.6 times this 1,000, which is equal to 500 plus 600, which is equal to 1,100. So that would correspond, so this right over here would correspond to, so 1,000, so this might be 1,000 in this axis, so this would be 1,100, to this point right over here. So that would be the coordinate, 1,000, 1,100. And this is a line, so 2 points make a line, and so you would have, so in this particular case, we have a consumption function that looks something like this. Looks like that. We've picked 2 points to draw it. If you remember a little bit of your slope, you could view this as your y-intercept, or in this case your c-intercept, and that your slope would be the 0.6, and we'll talk more about that in future videos when we dig into the marginal propensity to consume a little bit more. But the one thing I just want to highlight is it's a very simple idea, and this does not have to be the consumption function. The consumption functions that we tend to study in introductory economics classes will look like this. It'll be a line that has some intersection, some base level of consumption, but one could argue it might be very different. Maybe the consumption function looks like this. Maybe when income is low, for every incremental dollar of income, people are probably going to spend a lot. And as they become richer and richer and richer, as their income goes higher and higher, they're going to spend less and less a fraction of their disposable income. So essentially what I'm describing here is a marginal propensity to consume changes. In our first model, we had a very basic marginal propensity to consume. It was constant. For every incremental dollar, 0.6 of that got spent. So we had a marginal propensity to consume that was constant of 0.6. Marginal propensity to consume. But you could argue that maybe a more complex model's justified. That when you have a very high marginal propensity to consume, when people have very little because they have a very low standard of living, they really want to just get a little bit more just so they can live a decent life. But as they get more and more income, they say, hey, I already gotten kind of starting to max out my standard of living. I'll save more and more of it for a rainy day.